Hello, ladies and gentlemen. I hope I'm going live about now. I apologize for the stream being very off the cuff. I obviously didn't have much time to prepare for it, nor did I prepare you, my audience, for the idea that we would even be getting a stream today. So I fully expect the stream to have like 0 viewers or close to that. Basically, I didn't know when the review embargo for the Ryzen AI 300 series would drop, which, for your information, are the latest Zen 5 and Zen 5C based laptop processors from AMD. And to me, it was very important to cover this as early as possible. Obviously, this will be a developing story because for now we only have a limited number of reviews. A lot of those reviews, unfortunately, are sponsored. Now, what I'm looking at here, of course, is usually the creme de la creme of laptop chip reviews or in general processor reviews, and that is of course AnandTech. And this is what I want to start. However, we can go over to YouTube. I did, for example, pre-download the latest Max Tech review for the Asus ZenBook S16 and the review from the Hardware Canucks guys. Of course, I'm open to suggestion from you guys what I should pay specific attention to. So there is a lot that we could potentially cover here, but I think we'll also try to cover over the next 2 or 3 videos. Of course, depending on if we also happen to get any surprise new Apple information, then that usually takes priority. So that's about the outlook for today's video. As always, I highly encourage you guys to subscribe, like the video, share it out, comment. As I always say, I love me a lively live chat. So let me know what you agree with, what you disagree with, make suggestions. All of that is very much appreciated. If you want to support this channel directly, you can leave a small donation in the form of a super chat or a super sticker right while I'm live, or you can become a channel member. Shout out go to Angelica and Max Maximus, who are MarkTech Pro Max supporter right here on YouTube. And you can also become a long-term supporter of this channel on Patreon. Shout out goes to Louis God, who is our MarkTech Pro Max supporter over there. So, of course, any kind of help is very much appreciated. If you like the fact that I can get ready for you on Sunday evening at 8 p.m. and to talk with you about chips, then, of course, if you want to show your support for that, I would very much appreciate that. So let's start with what we actually have in front of us today. Primarily, we will be dealing with one specific version, which is not the highest end version of the Ryzen AI 9 series, or just in general Ryzen AI 300 series, with 9 being the most upper end sub-series. However, 9 does not apply to only one processor. I believe it applies to both the 370 and the 375. The 375 is a chip we don't yet have access to in terms of reviews. So the most high-end chip we are talking today is the AMD Ryzen AI 9 HX 370. So if I ever mispronounce that in any way, either the AMD, the Ryzen, the AI, the 9, the HX, or the 370 part, please forgive me. It's a rather stupid name. Of course, the AI was bolted on to the naming because it has a much faster neural processing unit, up to 50 teraops. How relevant that is for your regular Windows operations and most of your apps and games remains to be seen. It should be noted that while it is a Copilot Plus ready PC, it does not actually have the full Copilot Plus suite of features, because those are right now primarily optimized for the latest Qualcomm chips, but they will be coming to the Ryzen AI chips and Intel's Lunar Lake processors later in the year. So it's a little bit of a messy situation when it comes to software, when it comes to branding, but this is what we're looking at. Now, obviously, this is the chip. This it's actually a very interesting chip because technically it has a lot of new stuff in it. Primarily, when we are talking about the most high-end versions, we are talking about like 4 Zen 5 cores. So that's a new core design. Still on, well, it's an upgrade over Zen 4, like regular Zen 4 being on 4 nanometer, on 5 nanometer from TSMC, but it's not really a big node upgrade over the 8840H chip or something like that, because that was already on 4 nanometers. So there is not a big node jump. At best, we're jumping from N4 to N4P. So, however, it seems like AMD has actually pulled off some density increases here. Unfortunately, no clock frequency increases. The IPC increase is decent. We will be looking, of course, into the exact data that is provided in the reviews. The GPU is up to, I believe, up to a 16-core RDNA 3.5 chip with I want to say XDNA. Yes, XDNA 2 AI processing abilities. So there's a lot of buzzwords being thrown around. It's basically a brand new generation in a lot of ways. The main CPU cores, the auxiliary CPU cores, the GPU architecture is not a brand new one. RDNA 3.5 is not a full redesign over RDNA 3. However, it is supposed to fix certain inefficiencies, especially when it comes to latency that we kind of observed with the original RDNA 3 launch, especially for the desktop parts that, of course, also have chiplets for memory controllers. Now, whether or not RDNA 3.5 is also a big benefit for laptop chips that already were like single die based, that remains to be seen. Now, with everything that we're also covering today, we are not just covering the 370 specifically. We are talking about its specific implementation for the most part in the ASUS ZenBook S16 laptop, which does mean that it has a theoretical power maximum of 33 watts. Now, that's a power profile, so it can go above, can go below, but that's about where you should expect it. That is not the highest end capability even this chip is capable of. In fact, when you look at the exact breakdown of the generation, we do look, of course, at the 365. I apologize, earlier said a Ryzen AI 9 included 2 chips between 375 and 370. Apparently, it does also include the 365. I suppose that, which is weird because I knew that the 365 had like cut down Zen 5C cores, so it has fewer cores and fewer threads, and it has fewer compute units for its GPU. This is why I was confused why the 365, even after losing DHX branding, is still in the Ryzen AI 9 family. In my opinion, it should be dropping to the Ryzen AI 7 family, given that it has fewer cores, worse frequency, and fewer GPU compute units. Now, what you will find that is very confusing, and I will never understand why that is even allowed in the first place, is that when it comes to the TDP, the actual power range for all those processors is exactly the same. You can configure those chips between 15 watts and as high as 54 watts. Now, as I said, even the 370, which of course is a fully enabled chip, like all 16 all 16 compute units on its Radeon A90M, all 24 threads on its 12 cores between 4 Zen 5 and 8 Zen 5C cores. It actually even has the same peak clock frequency on up to a single threaded Zen 5 core, we're up to 5.1 gigahertz. I actually thought this would be only up to 5 gigahertz. So I don't know if I got that wrong or if they are getting it wrong. So of course, and we will be like looking into this over the next couple of days and weeks. The cache amount is the same. The only notable downcut, and this likely comes only from a small difference in clock speeds for the neural processing unit, is that the NPU does perform up to 10 10% better, up to 55 trillion operations per second on the XDNA 2 NPU on the Ryzen AI 9 HX375 versus the Ryzen AI 9 HX370. So, and of course, when we look at down to the Ryzen AI 9 365, we find that it does have it's very fast neural processing unit at up to 50 tops. And when it comes to, of course, everything else, as I noted, fewer Zen 5C cores, fewer RDNA 3.5 compute units. This is why also there's a different branding for the integrated GPU. So if you were not confused enough by the amount of sub-brandings included in those chips, yes, the integrated GPU also does get a different naming, even inside the Ryzen AI 9 family. So this is where we get 12 compute units. We do not have different advertised like peak clock speeds for the GPU, whether those vary chip by chip or whether those vary only between different configurations that are sort of laptop specific. And when it comes to the actual CPU, this is where we see a very small downclock on the 365 from 5.1 gigahertz down to 5 gigahertz on the Zen 5 cores. Of course, that's only for single-threaded. And when it comes to the Zen 5C, this is actually very interesting. This is a piece of information I've been looking forward to getting for a while now. And the reason why is because the PlayStation 6 is actually rumored to be getting like a course based on Zen 6C or maybe even Zen 7C or whatever. And for that, it obviously needs to at least match the clock frequency of the regular PS5, which is 3.5 gigahertz. Now, granted, given that Zen 6C is likely going to be an upgrade over Zen 5C, we should at least be getting 3.5 gigahertz there. But then there was also a discussion about the PS5 Pro, because it's Zen 2 based, technically desktop Zen 2 based, though it does cut down a lot on available cache versus its desktop counterparts. That one goes up to 3.8 gigahertz. And this is where I am actually inclined to believe the theory that Sony is deliberately like limiting the PS5 Pro to not potentially reach 4 or even 4.2 gigahertz on its CPU, because that would create forward compatibility issues with an upcoming PS6. Because if a PS6 can only run at up to, let's say, 3.8 gigahertz on a potential Zen 6C or Zen 7C CPU, that would create issues, even with a higher IPC, given that the console APIs are written very, very close to the actual metal, to the specific processors. It stands to reason that you would need to at least exactly match the clock speeds to really achieve the same results. And then, of course, you can use the increased IPC to achieve even greater frame rates on the same frequency. So, but there wouldn't be like any timing issues, any latency issues when it comes to stuff like that. So this was personally very interesting to me, because I'm a PlayStation gamer. I own a lot of Apple technology, which, as you guys know, is obviously not necessarily the best when it comes to gaming, when it comes to the app selection, even though I would argue the actual performance is really good. So yes, this was one thing that I was really excited about to know. When it comes to base frequency, they're all at up to 2 gigahertz, which I assume is kind of like necessary to still manage background processes in an efficient way. It cannot be too lower, or it just won't be able to handle the tasks. It cannot be too much higher, or it just won't be efficient enough. But of course, the actual chip that we use does not define the wattage that is being consumed. That is being defined by the motherboard manufacturer, the laptop manufacturer, whoever configured the BIOS. So yeah, between 15 and 54 watts, there's a wide range of results that you could be looking forward to. We don't know what the scaling looks like, so I'm very much looking forward to getting some of those chips, maybe like the Ryzen AI 9 365 inside like handheld Windows gaming devices. I think that will be interesting to see whether like a notable like reduction in wattage or something like that actually matters, right? If you have like fewer compute units, if maybe like the bandwidth is already maximized with 12 compute units, unless you overclock it, or maybe if you only run it at 20 watts, it doesn't matter if you divide those 20 watts between 16 compute units or 12 compute units. So that is also something, again, that to me, at least like gaming adjacent, is very interesting to know. Now, they do compare it, of course, a lot architecturally to the Ryzen Mobile 7000 and 8000 generations. Those, of course, were like, especially like the 7840, the 8840, like those were kind of like the predecessors to this, and those are the chips currently powering most of the Windows handheld devices. Now, they did have like different subvariants before that jumped from like 15 to 30 watts. That was called the U series, or the HS series that was for 35 to 54 watts. You can actually see that the power range is still the same, but this is not differentiated anymore in branding. Instead, the branding primarily applies to core counts, and even to a higher degree than previously to the capabilities of the NPU. So the fact that the NPU here delivers up to 55 instead of 50 tops is actually a kind of reason for them to rebrand, even though basically all the rest is the same, which is kind of insane in my opinion. But this is where we are with the current AI craze. So they do try to break down the lineup a little more here. Obviously, you can sort of try to compare the NPU based on trillion operations per second numbers. I highly discourage you guys from doing that, because obviously any kind of task that uses AI should also, especially on Apple's chips, be partially capable to leverage the graphics or even the CPU to a lower degree. Of course, the entire package is very bandwidth limited when we are talking about APUs. Yeah, never let any manufacturer tell you that, oh, I have a little more tops, that means my chip is the same. So take it however you want. Commander Striker, I don't think I've ever seen you in the chat. Welcome, brother. Yours declaring Intel for life, yo. I definitely don't agree with that as an Apple Silicon user and as a PlayStation 5 user. But of course, I do like me a strong rivalry between like big processor companies. I think it benefits all of us to see healthy competition, to have one company leapfrog the other 1 year, then the other follows it up, or they reduce prices. I think in the end, we all benefit. So again, we did talk about the different breakdown between like 4 Zen 5 and 8 Zen 5C cores. Zen 5C is of course lower clocked, but it's also more dense, which means it has less cache. But theoretically, that lack of cache kind of gets sacrificed for the clock speeds, which I didn't even think that scaling could work that way. So AMD often talks about how the IPC between regular Zen and Zen C is actually basically identical, but just Zen C is completely incapable of reaching the higher clock speeds. It's just not optimized for that. It doesn't have the cache for that. However, both of those core types are capable of simultaneous multi-threading, or as Intel will call it, hyper-threading. That means you get 2 threads per core, which of course compares favorably versus Intel's upcoming Lunar Lake, where both the performance and the efficiency cores actually gave up on hyper-threading versus previous generations. So Intel's upcoming laptop, let's say flagship, even though it's technically not designed to be one, will have 8 threads versus this having up to 24 threads. If you want to compare that to Apple's or Qualcomm chips, it's actually pretty easy always because ARM chips, at least the ones we have right now in most processors, do not have SMT. You usually get one thread per core, no matter whether we're talking performance or efficiency cores. So, for example, I think M3 Pro that has up to 6 performance cores, up to 6 efficiency cores. So that will give you up to 12 threads. However, of course, threads can vary very much between different processors. Performance can vary differently between threads. The highest reachable clock speeds can vary. More threads doesn't necessarily mean more multi-core performance, but it can mean that. And now I need to take a sip of water. And while I do so, I highly encourage you guys, again, we actually have more people watching than usual, to consider commenting on the video, liking, sharing, subscribing. And if you want to leave for a small donation, you can leave a super chat or a super sticker right here or there, or consider becoming a channel member or a supporter on Patreon. Link is in the description. Now, of course, AnandTech and other PC hardware websites do have more detailed breakdowns of the Zen 5 microarchitecture. That will not be the subject of today's videos. Nor will it be really like trying to fully define RDNA 3.5 versus RDNA 3 or XDNA 2 versus XDNA 1. Basically, for detailed architectural breakdowns, there are far better channels than this one. This is obviously primarily an Apple-focused channel, but we don't even do architectural breakdowns for M-series processors, so don't expect me to start doing them for AMD or Intel. Now, this is the laptop we are currently getting. This is the Asus ZenBook S16. This is the 2024 version. So obviously from the name, you can kind of gather this is a 16-inch laptop. It has a 2880 by 1800 OLED display with up to 120 Hz refresh rate. However, it is not the brightest panel, 400 nits. It can reach HDR brightness at up to 500 nits. So it is usable, but of course, Apple's laptop screens now reach up to 600 nits of regular brightness, up to 1600 nits of HDR brightness. And of course, if you want to have basically the perfect OLED panel, you should kind of be looking at the M4 iPad Pro that reaches up to 1000 nits in SDR brightness and 1600 nits in HDR peak brightness. So, however, this is a good panel in general, right? So especially if you plan on using it at home and you don't need much peak brightness, and you probably even wouldn't want to, because OLED can suffer from some color inaccuracies when you really pump up the brightness. Of course, the efficiency goes away to a large degree. So this is a 100% DCI-P3 color gamut display. It is certified for HDR True Black 500. So at least that HDR experience, even though it's not a very high peak HDR brightness, will be a good one. You have a large trackpad. You can like or dislike Asus keyboards. I'm pretty much very neutral on them. When it comes to Asus in general, obviously Asus has suffered a lot in recent times from a lack of trust from customers, as they've refused to acknowledge manufacturing defaults, defects and stuff like that. But I don't want to comment on that too much, because I know that they've corrected some of their behavior. I know they even went out and contacted Gamers Nexus. They changed some of their RMA rules. So if you choose to trust Asus, that's up to you. I do not have enough information, neither personal nor auxiliary, to make that decision for you. When it comes to the actual laptop design, though, I do want to briefly mention that I very much dislike how the speaker slash ventilator grill, I don't know which part it actually takes here, is positioned. It just just looks very asymmetrical, the way it all sort of like, you have these bezels around the keyboard, which is similar to how the MacBook Airs look, because they do not have the large speaker grills as the MacBook Pros, but those go around the keyboard, they hug them on the MacBook Air. This just looks like you also have like zero space between the keyboard and the trackpad. It just starts. Here, it looks like the speaker is almost like a separate module that was kind of fitted in there, and it doesn't reach quite to the end, which that I'm perfectly fine with. That's what often happens with hinges. But because of the very, very clear like color contrast, and because all of those like separate lines, it becomes more pronounced than any other hinge I've really seen stand out in recent memory. Again, it's not ugly, it's criticism kind of on a high modern level where I expect laptops to look a certain way, like a very finished way. I can kind of feel that this is designed to be a pretty not cheap product, but a less expensive one, right? So it like uses a relatively low power processor at 33 watts, so it doesn't need too much cooling. Once you save money on that, you can focus on making it very thin and light. When you make it thin and light, there is no reason to really go overboard in things like having the best speakers and stuff like that. So one compromise kind of starts hunting the next, and you end up with a design that kind of feels unfinished. At least that's my opinion. You don't have to hate it. But of course, guys, as always, let me know in the comments if you agree with or if you disagree with, if you would like to cover me something very specific. But for now, like, again, like, there is nothing bad here. Like, if there is something bad here, that will be up to like very detailed reviews to find out, and of course by actual consumers to find out if there's any like defects with the device. There are different configurations. This specifically is a 32 gigabytes of LPDDR5X configuration. The memory here should have a bandwidth of like 135 gigabits per second for no, wait, what was the peak RAM speed on this unit? Oh, it's 7500, then it's 1200. Then it's 120 gigabits per second. I apologize. I thought it had like 8500, similar to the latest Qualcomm chips, but it seems it's limited to 7500. Just for context, Apple just started using LPDDR5X 7500 on the M4 processor. So this is where Apple actually, on a 128-bit bus, offers the same memory bandwidth, at least for the GPU. When it comes to the CPU, Apple is kind of legendary when it comes to leveraging memory. They're kind of the only manufacturer where even just a single CPU core can leverage the entire memory bandwidth. But yeah, it's not bad, right? It could be higher. We've already seen higher from Qualcomm, but it's not bad. It's a 1 terabyte device. It has Wi-Fi 7 and Bluetooth 5.4, so it has a modern module modem. It has a large battery at 78 watt hours. Granted, if you think about peak power consumption, right, at 33 watt hours, that's like 2.5 hours of battery life just at max speed from the processor itself. Obviously, then you have to consider stuff like power draw from the display and things like that. And of course, most of the time you will be running the chip at significantly lower wattage than that. So you kind of need that, unless you really try to put it at like 18 or 20 watts most of the time. You kind of need it if you want to leverage its full performance. It's relatively lightweight at 3.3 pounds. It's $1,700 in this specific configuration, which obviously compares nicely to something like the MacBook Air, which at this price doesn't offer you an OLED screen, doesn't offer you 1 terabyte of storage, doesn't offer you 32 gigs of memory. So there's definitely a lot of good stuff here versus something like a 15-inch MacBook Air. This is why I've historically said it's very much time for Apple to increase base RAM configurations and base storage configurations on their laptops at this point. So when it comes to power consumption and power modes, to be more precise, we do have like the 33 watt TDP here for this device and this specific processor. We do 33 watts peak power, which I believe in a 28 watt TDP. You have obviously AMD's own previous generation, the 7940HS or the 8940HS. I believe I used to say 8840HS. I don't even know how much of a difference there is. All the branding is so stupid with why do you ever need 1,000 in the name? This is geez, I never liked that. At least it's now three numbers instead of 4. It's so stupid. But now we have even more letters and numbers before that, so it didn't really get better. And of course, when we try to compare to Intel's current Meteor Lake chips. Is the this is Meteor Lake Cool Ultra 7 155H. That one goes up to 64 watts. Now, granted, all of that can run even higher. It's just this is specifically what was chosen for this review from AnandTech. And of course, you can run them in different power profile modes. Those are very laptop dependent, so I'm not going to go too deep into them because those will just vary from manufacturer to manufacturer, from laptop model to laptop model, and things like that. So single and multi-threaded results, I don't think we need to get too much into things like clocks into core-to-core latency. So this is spec 2017. We're kind of overdue a new spec version. I believe the last update was 3 years ago or something like that. So when it comes to the M3, you can see it winning here. What is that, single core versus multi-threaded? This cannot be. The M3 cannot beat those cores. Even those older chips, they run at such a much higher wattage. Of note, it should also be noted to note the requirements. In its highest performance configuration, AMD is touting a 16% average IPC uplift for the Zen 5 architecture, but this is the full-fat configuration of a 512-bit wide SIMDs for single-cycle AVX 512 support. What StrixPoint offers is a bit less, with just 256-bit wide SIMD. So this is even not quite the exact Zen 5 that you will kind of see on desktop. So expect the IPC increases over last gen to be a little less impressive here than on desktop. Coupled with that, Ryzen AI has a peak clock speed of 5.1 gigahertz versus 5.2 gigahertz on the 7940HS. So there's a slight regression here in terms of clock speeds. Now that's very interesting. I actually forgot that the 7940HS could reach such high clock speeds on Zen 4. So you kind of need to have even more IPC uplift to actually see those benefits. I don't know. What is that this is integer versus floating point performance. Oh, okay. So M3, for some reason, having a huge advantage in integer, and then in floating point, kind of matching the HX 370, while still beating in a surprising way for me the 7940HS and the Intel Core Ultra 7 155H. I just don't know if this is a multi-threaded task or not. It should be done to keep apples to apples. Say that any benchmark have to be labeled estimated, which is comparable inside, but it's not strictly the same either. Because if it were single-threaded, that at least would make some sense to me. Because like Apple Silicon kind of is legendary for single threaded performance, but this one has a lot more power right now and like higher clock speeds and stuff like that. So it kind of would make sense for me that Zen 5 on laptop could match like single core, at least in some ways, versus M3, but I just don't know. Um, it looks far better in terms of floating point performance. Yep, versus integer. Um, so here again, we have M5, M3, I apologize, in black, competing with the rest, beating everything in every single benchmark except for M4, 541.lila/R, underscore R, I apologize. And then winning in some of those tasks, like in very, very dramatic ways. Jesus Christ. Crossing the H7 does more often not pull ahead of the 7940HS. However, we also see more than one instance of the newer chip falling behind. I'm a bit curious if we are seeing some memory interplay here. The 7940H system has DDR5 versus LPDDR5X on the HX370. Could they not have found like were there 7940 systems that held LPDDR? I thought they did, because they are like laptop focused. So LP stands for low power, but there's not quite enough information to draw in conclusion. Shifting gears. Okay, so this was apparently all single-threaded performance, so that at least makes some sense. Now, there are some tests here where the M3 then starts to get beaten in certain results. I have no idea, to be quite honest, what those individual results mean. This is why we have experts like AnandTech doing these checks. It should also, of course, be noted, as I said time and time again, at this point, spec at this point is not ultra new. But so maybe some of those chips that are focused primarily on newer instruction sets are not as fully leveraged as they could be, but those are still, from what I can see, good results for the Ryzen AI 9 HX370, and of course still a lot of very good results for Apple's M3, which of course, as an Apple focused channel, this is a sort of my focus here as well. Let me just briefly check if my stream is working all fine. Yep, should all be working good. Let's look at multi-threaded results. Or did they write here that it was single-threaded at the very end, at the very beginning? Oh, single-threaded, RAID 1 results. Okay, I'm just stupid. I apologize for that, guys. So when it comes to multi-threaded, if they did more benchmarks for Apple, I would be more often on this website, and I would be learning how like their graphs work and how the structure of their articles work. This is unfortunately always the issue when you usually look at very different tests. So let's see, when it comes to multi-threaded results, this is not possible. The M3 is like an 18-watt chip. Like, how is it matching this? But yeah, good news for the Ryzen AI 9 HX370 at 28 watts. It beats the 7940HS at 35 watts and the Core Ultra 7 155H. Now, this does say 28 watts, but they did show that its actual power consumption is significantly higher before. Let me briefly look into that. Yeah, so this is, by the way, when Intel, Intel, yes, but also just in general, Windows processor manufacturers give you like a TDP. Never take TDP to mean actually anything. Like 28 watts quickly turns to 64 watts, and we are at over double the power consumption that the TDP would imply. TDP has way more to do with like the implied necessary cooling for a processor, but at peak, even if it's a very slow, very short burst, it can consume quite a lot more performance. Then it quickly throttles down to reach an equilibrium. Whether or not that equilibrium is actually close to 28 watts, or it still might be like 40, 45 watts, will depend on the actual like laptop that it sits in. Single multi-threaded results. Nope. Return to whence it came. So multi-threaded results here. Where were we? So we had this is again integer versus floating point. We have the M3 still beating the last gen AMD and the current gen Intel, one might say, actually incredibly significantly, especially to Intel. And then at floating point, we can see how x86, maybe that comes with just the larger instruction sets of obviously versus RISC architecture. It does sort of like, it still pulls ahead, but not by quite as much. And it basically matches the HX370 in most ways. This is, of course, bad news for everyone who still wants to like claim the performance crown over Apple for this year, because Apple still has the M4 chip, which runs it up to like 8% higher clock speeds and has like 8 to 15% higher IPC depending on the workload. So it easily will give you like 20% more performance. And this is where, of course, even if just half of that is transferred to a test like Spec 2017, it pulls ahead of AMD, and it just leads in the dust like Meteor Lake. So hope that Lunar Lake does something, but Lunar Lake might then also suffer from a degraded multi-threaded results, because of course it has significantly fewer threads than the Intel Core Ultra 7 155H. So those are the breakdowns of the individual results. They do, of course, on average line up with the results we got on top. System and storage performance, what does that mean here? I believe this is where they won't include Apple's chips, because those are just tests that are either not really optimized for for Mac OS, or they're just like completely designed for like system level performance on Windows. So it just wouldn't even make sense to really port any of that, or it's like office test for like Word and Excel and Outlook. And yeah, I just remember whoever makes those benchmarks doesn't care too much about how those perform on Apple Silicon. But you can see it doesn't actually win here. So that's interesting. It actually falls behind both Intel's current gen and AMD's own last gen, actually quite significantly. Whether or not this basically has entirely to do with consumed power, though, which would line up pretty much with the gap we see here, remains to be seen. And we actually see that being replicated across Word, Excel, Outlook, PowerPoint. It does win in Jetstream. How much performance you need there is somewhat questionable, given just how fast modern chips are for those kinds of workloads anyway. I don't know what this test actually does, so I'm not going to comment on it too much. Beyond that, it does not actually beat their own last generation processor. Now, of course, those are laptop specifics, so you can easily imagine a higher like a TDP, even HX370, much less the 375, could pull ahead and will likely pull ahead of the 7940 HS. However, the question is, what power will it consume in order to achieve that? That's kind of my question. Now, it does have PCI Gen 4 SSDs. Doesn't really fully leverage them, but at least it's still faster storage than what Apple has on the MacBook Air, but it's quite a bit slower than what Apple has on the M3 Pro MacBook Pro. Um, Encoding performance, there is a new encode engine. So this is actually where it does pull ahead over. Wait, no? I've seen reviews at this point. What is happening here? That's AV1. So it loses in AV1. We've updated our list of encoding benchmarks for our 2024 CPU suite to include some of the most relevant and recent codecs, such as AV1 and HEVC. Well, yeah, you should have included HEVC for years at this point. Not only this, but we have also WebP2 image encoding, okay, to show not only how the latest processors perform with these codecs, but also to show discrepancies in performance throughout the different segments. So in WebP2, it pulls ahead, but still mostly matches the 7940HS. When it comes to AV1 encoding of a 1080p video, it actually is the worst, because this is, notice guys, this is not a time measure where it would be the fastest by having the lowest number. This is a frames per second number, which means it obviously would need the longest amount of time. Then we have an AV1 encoding for 4K. Now it pulls ahead of, surprisingly, both Intel and their previous generation. It somehow manages to lose still to their previous generation on the Razer Blade 14 with 35 watts. Again, stuff like this could depend on power. There is also, of course, the bandwidth consideration between using LPDDR5X and DDR5 memory. So take it as you will. Unfortunately, this does seem to be a device that is quite limited and does not do the best job of showing off the capabilities of AMD's latest generation. What else do we have? We have it winning in another 4K test. AV1. Now we come to HEVC. Somehow it manages to lose. Again, I'm inclined to believe that those might be differences based on raw power usage, and when it comes to bandwidth available through LPDDR versus DDR memory. Now we see it matching the previous generation, which is interesting because I often hear from people that the QuickSync, I believe, on Intel is still like ahead of AMD. I don't know if they just mean in terms of like maybe quality, but it definitely seems like in raw performance, at least to these AnandTech tests, like AMD does pull ahead even with the previous generation. So maybe that's like a wrong, maybe that's like a misconception by a lot of people, or maybe it varies depending on which kind of like video editing software you use. But at least in these specific tests, it seems like AMD is kind of the winner for the most part. In 7-zip, it does win here. I believe this should be like multi-threaded base, so yeah, I would expect a 24-threaded chip to win here. Obviously, Intel really sucks, especially for its high power consumption here. So this is compression, this is decompression. So nothing too surprising on this. On the encoding, it's not as big of an uplift over previous generation as I expected, because AMD specifically talked about that being better. However, the fact that it already kind of won against Intel, even with their previous generation, that came as a surprise to me. So we'll see how actual like real world tests make that look, if it might perform better or worse, and what people say, like more professional reviewers, things like that. So I believe that leaves us with GPU and AI performance. So this should be rendering on the CPU. This is using Blender 3.6. This is where it does pull ahead. I don't know if that uses like AVX 512 wouldn't even matter too much, because as we've talked before, the laptop Zen 5 is not as big of an upgrade over Zen 4 as desktop Zen 5 is going to be, but it definitely does pull ahead of the 7940HS. They do not, do they say power consumption here? Because I would love to see power consumption specifically for like both single threaded and multi-threaded, but they do not seem to giving that. I think those would be very, very interesting numbers to see. That's unfortunate. So this is higher. Again, they do not say when they're doing single thread. Like, am I just stupid? Blender 3.6, BMW 27, CPU only. Also, in this section, so simulated tests, including our typical gaming simulation benchmarks, which consist of Dwarf Fortress and Factorio. Dwarf Fortress and Factorio are very like simulation intensive gaming benchmarks. Let's call them what they are. They are specifically like benchmarks almost. They do not really reflect most of the kind of games that people play, but specifically if you're really looking to like almost scientifically analyze like where CPU bottleneck would lie, you would probably look at something like Factorio rather than like a Cyberpunk, which might in certain scenarios be CPU limited, but for most people it is more likely to be GPU limited, unless you have like a crazy maybe like a Ryzen 3600 and then an RTX 4090 combo. You're very likely to be more GPU limited than CPU limited. So it pulls ahead here. It wins against all the other chips. Keeps doing so. M3 in single threaded, just completely unmatched in Cinebench. This is actually fascinating because just not too long ago with Cinebench 2023, like I believe it was still then called like R23 or something like that, Apple Silicon just sucked, and Apple users were trying to tell people, no, this is just a bad benchmark. Cinebench is derived from Cinema 4D. There's, for one, it's already silly to run this test on a CPU, but just using that for Apple Silicon, which already doesn't really do anything with Cinema 4D in general by most users, that was weird. I believe it's Maxon, the company, came out and actually fixed at that, and now we see absolute supremacy by Apple Silicon. Again, this is not even the best that Apple Silicon has to offer. There is the M4 chip that, as I said, has 8% higher clock speeds, or 7 or something like that, I guess. Like, let's say around 10% IPC improvements. It will just keep demolishing all of that. You can already see here that we do not see like a 16% IPC uplift. Again, granted, those could be things that are limited by wattage and stuff like that. It really shouldn't be, at least not for single thread. Your single thread performance really should fit nicely, whether we are talking about into a 28 watt TDP or a 35 watt TDP. But we can see a small uplift nonetheless, and one that makes it the fastest x86 laptop processor in general. Cinebench 2024 multi-threaded. You can see this is where DM3, of course, consisting out of 4 performance and 4 efficiency cores, 8 threads, starts to fall behind something like the 8 core but 16 thread 7940HS, which consumes like up to double the power of DM3. It's amazing that DM3 even comes that close, even with its noted advantage of 3 nanometer versus 4 nanometer. That still is a very good result for M3, by the way. terrible results for Intel. Didn't even expect them to be this bad. And then of course our 24 threaded chip gets the best results. That's not too surprising. Some V-Ray tests where they win again. Now we look at our simulation gaming stuff, and we actually see it losing in Dwarf Fortress, and when it comes to Factorio as well, which is really fascinating. That might be like microcode problems. Maybe it's just not optimized, or it's simply really an issue with power. It could be. So, what do they say about simulation here specifically? Despite winning the battle in rendering performance, we see the tables turn in both our gaming simulations, which consist of Dwarf Fortress and Factorio. In this scenario, Intel takes the lead, although in the 3D Mark CPU benchmark, the Ryzen AI 9 HX 370 comes out on top with 1 thread, 8 thread, and the maximum number of threads available from the chip. That should be noted. Some apps obviously might not even use all 24 threads, so but they might actually force the chip into a higher power consumption mode. So it might make sense to maybe in firmware like limit the amount of threads dedicated to a specific application and get just the best, most efficient results. However, that is more tinkering than I would ever expect the average user to do. Sometimes, though, you can configure it in an application, so that helps. AI performance, this is actually something I haven't seen anyone else do. And this is where, to me, it gets really interesting because obviously, this is what this chip is named after. It is AI focused, at least in branding, and you can see that its uplift over the 7940HS, which actually supposedly has an inferior AI engine to even the 8940HS, it actually doesn't pull too much ahead. In fact, here we even have like the 7940HS winning. So I don't know what up with that, to be quite honest, but it is definitely outperforming Intel in this result. Intel has a very below average NPU on Meteor Lake. Their first truly modern NPU is coming with Lunar Lake. So yeah, it's definitely kicking butt here, but it's not as big of a generational uplift as one might think from the marketing that they have talked about versus even their own previous generations. As we've said, benchmarking AI is currently something of an oxymoron, as AI models and LLMs are constantly evolving and changing at a rapid pace. There isn't a defined benchmark that tests AI performance from a level playing field. That's also true. Some like not necessarily LLMs, but like some AI workloads are very much more optimized these days, even more for NVIDIA than anything else, right? So testing them on AMD and Intel might be just like a coin toss on if the developer bothered to do any optimization for either one. And in that case, it's usually AMD, because at least AMD has like high-end I thought somebody might have rung the door because AMD at least has like high-end desktop GPUs. Intel does not. Even their upcoming Battlemage generation of GPUs simply will not have that. So yeah, currently we're trying to come up with a way of testing AI performance, especially on hardware with dedicated NPUs. But right now, they just don't see how they can create a level playing field. So those benchmarks actually are very representative of like a best case scenario for each processor. What you can get from this is usually that I say that while I actually show a benchmark where the HX 370 loses to the 7940HS, but usually you can expect if everything else is equal power consumption, memory bandwidth, things like that, I would expect the HX 370 to pull ahead of the 7940HS. Of course, they both beat the Intel's Meteor Lake generation, and it remains to be seen, of course, how Intel Lunar Lake competes. And I would love to see more NPU benchmarks for Apple Silicon as well, to see how like trillion operations per second is truly a meaningless thing when you compare completely different architectures. But yes, if you expected to have like giant IPC uplifts across CPUs, if you expected like doubling of neural processing unit performance, you're getting none of that with the A9 series, the Ryzen 300 series, however you want to call it. You're getting meaningful but relatively small uplifts over the previous generations, and oftentimes you actually do need appropriately more power to reach those higher results. There's just not the kind of node improvement to also give this a major efficiency boost. It is more efficient, that's for sure, but it's not a massive game-changing experience. Speaking of game-changing, and I wanted to say that sooner, that's why I had issues. So when it comes to this, of course, this has up to 16 compute units of RDNA 3.5. Let's look actually the exact specification. Now, this is specifically the 7940HS. There is an 8940HS, but it doesn't change that much. So when we look at graphics capabilities, it goes up to 12 compute units. So this one, the new one, has 1/3 more compute units. This one reaches up to 2800 megahertz. I believe this is where we do see the uplift for the 8940HS. I believe this is where we do have... is it called something different? No. Oh, it's 8840HS. Wait, is there no 788? Man, my God, the branding is so bad. 8840. So this is why I've been calling it 7840 and 8840, because those are the ones I'm more familiar with. But like, is there really no 8940HS? Seems like it might have been just like a rumor almost. Oh, that's interesting. So it's actually hard to say which one will win. And now when we have, can actually just search the database for the AI. There it is, HX 370. Graphics capabilities. It is slightly higher clocked as well. Wait, why does it say... Oh, it's the DirectX version 12. But it does have 16 compute units. Yes, so this is the correct chip. And does the previous gen actually go higher? AI, does the 375 go higher? AI 9HX 375. Guys, we've been streaming for about an hour. As always, I want to encourage you guys, please subscribe to the channel. Anything that helps grow the community is very much appreciated. Share the video with anybody who you think might enjoy it. Comment. I love me a lively live chat. Of course, leave a small donation if you feel like it, in the form of a super chat or a super sticker. Or if you want to support this channel directly in the long term, you can subscribe to my Patreon or become a channel member right here. When it comes to graphics, no, still 2900. So there shouldn't be that much of a difference in GPU, except for, of course, that I expect most 375 chips to come in the higher wattage variants, closer to like its max 54 watts. Um, but we actually do see it winning both against the previous generation, and this is where one thing where Intel was actually performing pretty well. Its Meteor Lake chips had pretty good integrated GPUs. This does win against it definitely by like 20% often, sometimes a little less. But yeah, definitely a nice uplift. I assume if you get like, this is actually interesting, general specifications. Is there a highest speed memory that you can get? LPDDR5X 7500. Oh, so it's actually very likely to then, well, if it doesn't really come with like 8500 or potentially 9600 LPDDR5X, it really, like, I think Lunar Lake might actually win against this. That's interesting, unless Lunar Lake will be so power limited because it's designed to be small and really efficient. But those results really don't bode, in my opinion, too well for like the near term future, or like the long term future at the very least, where like M4 is coming out onto Apple laptops. Obviously, if everything looked like this, yeah, then it probably wouldn't have to fear Lunar Lake. But Lunar Lake is like rumored to be like 40% faster than Meteor Lake in terms of GPU. So that doesn't look too good. Something like that is definitely impressive. Um, but yeah, definitely. But it definitely is, by the way, the most efficient GPU here, right? Again, we do not have actual exact power consumptions over Intel's chips. It's very likely they consume significantly more power than their 28-watt TDP. Obviously, this is comparing to like almost like desktop chips that are designed to be like APUs. So not everyone has to like buy a dedicated graphics cards. This is at 65 watts. Obviously, this is running at like half the power and still beating it. So definitely, if you're looking into x86 gaming, this is for now the most efficient like APU on the market. Looking at the performance of the Radeon 890M within the Ryzen AI 9 HX370, we can see that the combination of Zen 5/Zen 5C cores and the latest RDNA 3.5 graphics performs consistently well at 1080p, given the Ryzen AI 9 HX370 has a higher core count compared to the well, yes, but that's also pretty meaningless because most games don't really need more than 8 cores. And you actually have the problem here that you have 4 Zen 5 cores. So you would have to really have an intelligent thread scheduler that puts the most demanding tasks always on the 8 threads available to Zen 5, while on it puts very, very little to nothing on Zen 5C, or like, and this Windows does sometimes have issues with that. But yeah, if you expect it to have like just a 33% higher GPU performance versus previous generation, you are not getting that. They say it's around 23% faster here, definitely in some results less. And of course, the question here is the wattage testing. Like, can you really completely match them watt for watt? But yeah, this is basically the Ryzen AI 9 HX370, part of the new Ryzen AI series. There are 300 chips, which does feel at this point as if there are 300 subvariants. But definitely nothing groundbreaking. I really think that this was probably designed to be on 3 nanometer at this point, which means you probably could have gotten like 10% more performance across the board, maybe like 5% more performance on the CPU, but maybe like 12% performance or something like that on the GPU. But alas, it is still 4 nanometer, it is N4P, so in that case it's actually doing quite a decent job, but definitely not a game-changing job. So that is, I think, the most detailed breakdown I can provide for you. Of course, thanks to AnandTech. Now, we do have a review by Hardware Canucks. Now, this is unfortunately sponsored, but so are most reviews that are coming out right now. There's also a review from MaxTech, which I haven't actually gotten a chance to pre-watch. I do want to see some more gaming stuff, so this is why or did the Fox do something? The Fox, the definitive results, videos. No, he has not. Has Hardware Unboxed done something? Because I would trust all of those guys versus Hardware Canucks, but yeah, they do not really run out to test laptops. Gamers Nexus. This is a revisit. This is an explanation of the delay for Ryzen 9000. Looks like for Windows stuff, we are now looking at Hardware Canucks. Let's see what they have to say. I think I'll try to speed it up. At 1.25. I might not be pausing too much because we've obviously talked a lot about it already. When they will be breaking down the exact architecture or something like that, I might skip over that because we've already talked about some of it, and we are a little bit time limited. So let me know. Mighty, welcome to the chat, or is it Malti? Saying hello to the chat, brother or sister, doesn't matter.
Refresh or rebrand, AMD is finally launching a brand new series of laptop CPUs. They're headlined by the new Zen 5 architecture, and it's meant to go head-to-head against the best from Intel, Apple, and even Qualcomm in the data market. Now, initially, there will be 3 processors launching. The Ryzen AI 9 HX370, which has 12 cores and 24 threads that can run from 2 gigahertz all the way up to 5.1 gigahertz.
Okay, so it seems like the 5.1 gigahertz that we saw from AnandTech was correct. I'll initially believed the 370 would be lower clocked than the 375, but it's not. And it does seem to confirm also a clock speed regression over something like the 7940HS, which was supposed to reach up to 5.2 gigahertz. Whether or not it actually reached it on chips outside of golden samples, I couldn't tell you.
The HX375 is just a copy and paste job with a faster NPU. Meanwhile, the Ryzen AI 9 365 gets 2 less cores, 4 fewer threads, and a 100 MHz cut in its single core clock speed.
It also has a slower GPU. Andrew Dufala saying, Just Josh has a really good breakdown with the data gathered over the past week of testing the new. I actually don't know who that is. I actually have to apologize. Just Josh. Oh yeah, I know that guy. I didn't know that this channel was called Just Josh. Just Josh. Sorry. Videos. Best laptop for students? No? It's a live stream. Yeah, live streams are difficult because I do have to consider you guys. Anybody who is here right now, I will promise you that this is not my last video checking it out. So if you want to subscribe, and of course, please hit the notification bell to be informed. And I do promise to keep covering this, right, guys? So for now, let's keep looking at this. But yeah, thank you. I do expect, by the way, guys like Just Josh, I just forgot what his channel was called, to do very, very good reviews in the long term. I expect the Fox to do good tests. I expect both Hardware Unboxed and Gamers Nexus to also do good tests. They are more desktop focused guys than laptop guys, but they still do decent laptop reviews. So I think over time we'll actually accumulate quite a lot of data on this channel, just as we did with the Snapdragon X Elite. Today's video is more of a singular look at the Ryzen AI series. It is not even a direct comparison to Apple Silicon, which was usually my focus when I talked about Qualcomm's X Elite processors. So yes, guys, please subscribe, hit the notification bell. It will help me tremendously. I love growing the community. I see a lot of new names in the chat. I very, very much appreciate your patronage. Just watching the video helps. Of course, leaving a small donation helps. Super chat, super stickers, becoming a channel member, subscribing to Patreon. I appreciate all of that, but also just you being here is already amazing.
comes with a cut-down 880M integrated GPU. Now, two major things they all share in common are
By the way,
vastly more...
like, can we briefly talk? And I said I wouldn't pause this video too much, but like, this is the Energy Star label, right? That's okay. You can argue, I would argue it needs to be almost like more pronounced than the rest. Do we really need like a Radeon graphics thing next to a Ryzen AI thing when they're both like part of one APU anyway? But the thing that really makes me clutch my pearls is an HDMI branding. Why? Why in the world? Like, it's not like HDMI is such a superior technology to everything else. It's like, do you get money from the HDMI consortium here so that you almost like shill for their tech? Like, that's just so weird to me, because it's not like, I mean, it's good to say this laptop has HDMI, but similar to how I wouldn't want a sticker that says that my Apple Silicon M1 Max 14-inch MacBook Pro has a 3.5 millimeter headphone jack, I don't need an HDMI thing. It doesn't, I believe it doesn't even say that it's like HDMI 2.1. Right? It just a high definition multimedia interface. Doesn't even say that it's like the best HDMI you can currently have or something like that.
Powerful NPU than the previous generation, and a configurable TDP of between 15 and 54 watts with a nominal default power setting of 28 watts. Obviously, one of the primary goals was to focus on efficiency, so Strix Point and Zen 5 architecture could actually maybe make these processors AMD's Apple M series moment.
Nope. Again, Apple's M series moment was so much more than just a slightly more efficient chip. There was a massive node jump, basically worth 2.5 nodes versus the last Intel chip that they used on their MacBooks, both because Intel was falling behind more and more behind TSMC, but also because they weren't even using the absolute latest generation of Intel chips at that point. So by the time Apple Silicon actually came out, it was significantly ahead of the last Intel-based MacBook at the very least. Of course, there is the jump from x86 to a RISC-based ARM architecture. Now, as I say time and time again, ARM by itself does not mean it's better than a RISC or than an x86 chip, but usually it is. In the way in the world we currently live in, reduced instruction set architectures do tend to outperform like x86 chips when it comes to efficiency. That is not a guarantee. We will see how that looks on Intel, where they have given up on certain things like simultaneous multi-threading on Lunar Lake, so they are actually following a little bit more into the compromise land that we see on RISC chips. So let's see if that helps x86 get closer again. And of course, there's also the difference between Apple Silicon came to Apple devices. It had a new version of Rosetta built for it. Apple re-architectured most of Mac OS. Of course, they had over a decade of experience with ARM-based processors for iPhones and iPads. They've already had pretty big ARM-based processors like the A12X before it, that was in the iPad Pro, that was actually in the Mac Mini based like Apple Silicon developer focused device. So yeah, this idea that this could come anywhere close to the jump that was Apple Silicon versus previous Intel based MacBooks, that is just completely ahistorical. Just from the fact that it's like N4 jumping to N4P, that alone is just such a laughably small node jump versus what Apple pulled off when they switched to TSMC's 5 nanometer with Apple Silicon.
But let's take a moment to check out today's video sponsor.
The new Tower 300
benchmark charts on fire. They'll even be fighting first.
Definitely explore the
Been seeing lately on the market. So the Ryzen AI series, they are meant to like a benchmark charts on fire. They'll even be fighting an uphill battle against Intel's Core Ultra 9 185H because the Intel...
Why is my question though? That has only to do with the power configuration. You have more cores, newer cores on a better node than what Intel has with Meteor Lake. You have a new architecture in general holding it all together. It's still a singular chip, right? There is no inefficiencies from like chiplet communication, stuff like that, like no bandwidth loss or something like that. Like why it wouldn't like dramatically pull ahead of everything else is just weird to me. Don't forget that Meteor Lake has Intel 4 as its node for its CPU. Then it has a 6 nanometer SoC tile that also houses 2 low power efficiency cores, but it also has a 5 nanometer GPU, actually TSMC 5 nanometer GPU based on Intel Alchemist's architecture. So it's actually like, at this point, it should be both architecturally behind AMD, except for maybe like ray tracing, because Intel AMD's big jump with ray tracing will come with RDNA 4. RDNA 3.5 pretty much does nothing in that regard. And they have here a newer node. It's all on N4P versus N5, N6 plus Intel 4 on Meteor Lake. It should be pulling ahead in basically everything versus the Intel Core Ultra 7 155H.
Chip has a much higher power envelope. So the better parallel would be the 165H and the 155H. Also for testing, we got 2 ZenBook S16s, one with a flagship HX370 and the other one with the 365. This is technically a thin and light laptop, but with a massive 16-inch screen. So its footprint is a lot bigger than typical 13 and 14-inch devices we see.
Yeah, it basically tries to spread it out, right? Which is pretty good. This is why like something like an iPad mini, talking now to my Apple-focused audience, can use something like the A15 chip at up to 7 watts, versus the iPhone being basically limited, or like even Pro iPhones with the A15 chip being limited to like 4.5 watts, 5 watts at most, while the iPad mini houses the same chip, has a larger surface area, it's an aluminum surface area, so even if it doesn't have as much dedicated cooling atop of the chip itself, it does have its larger chassis to help dissipate heat.
See in the segment. The specs are almost identical too, with the only major difference, other than the huge price gap, which is the memory allocation. But even in its slightly larger...
This is why I said, like, M3, I call it an 18-watt chip. I know it can go up to 22 watts. They show it at 21 watts. What is that metric? Is that idle? Because it power consumption, watts and power...
chassis. Check out how much little power these chips need.
And by the way, I do want to give a compliment here for like the actual like TDP coming actually close to the real power consumption. Obviously, this is not the case, as we've seen already with the AnandTech review of the Core Ultra 7 155H from Intel, and the Snapdragon X Elite, this being the 78-100 version, which actually isn't even like the most premium version in any way. You can see that this is actually really power hungry when you really stress it. That being said, it's not very optimized for Blender, so maybe it could be more efficient here.
Even with the highest performance modes, they sip a lot less power than the Ultra 7 155H in the XPS 13 and ZenBook 14 OLED. They even save 5 watts versus the Ryzen 7 8840HS, which might not seem like much, but in an ultra-compact laptop, it makes a huge difference, guys.
So yeah, okay, so 8840HS, they do not like, which again is pretty much like the 7940HS. Such a confusing effing like small gen-to-gen jump. This was like advertised to have like a 30% faster neural processing unit versus the 7000 series. This was so confusing, to be honest.
I mean, nothing can compete against Apple's M3 processor here, and I also need to mention the X1E 78.
And the M3 Pro should give you like 50% more power, right? Like 30 watts or something like that. But at that point, it will give you very, very different results, of course.
100. Since Qualcomm doesn't allow for direct power monitoring of their chip, the numbers you see here is how much the entire device pulls from between the
Okay, so it should be still coming in below.
USB port and the power brick. So it can't be directly compared to the rest of the results. I should also mention how we're testing other CPUs against the Ryzen AI series, because input power varies so much from one laptop to another. It's very challenging to do apples to apples CPU testing across different devices.
Unless
so
you compare apple to
was to
apple,
find
yeah.
as many thin and lights that use similar power envelopes to the ZenBook S16s. And even then, the Ryzen AI laptops were still the least power-hungry Windows-based devices we have ever got our hands on. And that could be a very, very good thing, because if the MacBook Air proves anything, high-efficiency CPUs are absolutely critical for ultra-portable laptops, since low power leads to less heat being produced. So these are...
This is the MacBook Air. It reaches, of course, on peak, very high temperatures. These temperatures are absolutely fine when it comes to modern silicon, usually up to 110, 115 degrees. It becomes a problem if it's entirely sustained. Usually doesn't sustain it. It would drop to around 92 watts, maybe like 92 degrees, maybe like 88 degrees when it comes to sustained stuff. Of course, you can then also compare the M3 based MacBook Pro and of course the M3 Pro based MacBook Pro. And while those do reach those peak like heat levels, they also then very, very quickly compensate for that, because their cooling system is way more than sufficient for the very efficient processors inside. It's just that Apple chooses to enable them usually quite late. So when you look at the 8840HS, you can actually see that at 95 degrees, Zen 4 in general tended to run pretty hot, especially on desktop. However, AMD has always said that is in operational spec. You can see that the Core Ultra 7 155H can have wildly different results based on the exact specification of the laptop and what kind of like performance and power consumption levels and targets. And the X Elite chip here, again, ignore the power consumption, as they said. However, it does get pretty warm as well, and we have seen from multiple reviews that, of course, the fans can get still pretty loud at peak performance levels, because it does have 12 essentially P cores. Their Orion main core design, so cooling that is not too easy, even if technically we are talking about it still being more efficient than the x86 chips that we see here. And yeah, a compliment here to the 365 and the 370. Especially like the 365, because we look at like a 33 watt like metric here, but somehow also a lot lower temperatures. So if you like a lot lower temperatures, either means you have like much better cooling, which I would doubt, given that this is the same device. So I would suspect that it does perform here lower as well, probably having like lower multi-threaded performance and clocking most of its cores for multi-threaded tasks significantly lower. And in that case, you definitely have to choose between best possible performance and a little bit more efficiency, quieter fans, a less hot device, and longer battery life. But those are the kind of compromises we always see. It should also be noted that Apple, like, you should never take the temperature of an actual processor to mean anything for the temperature of the chassis you're touching. That will depend on how good the chassis is at dissipating the heat. Even like internally, heat can be dissipated, but a lot of it will go to the chassis, and then it will depend on the exact materials that are used, how much there is, example, in terms of aluminum and things like that, how far away the actual chip might sit inside the device, so it doesn't it isn't there where you like really touch your keyboard and things like that. And Apple's MacBooks are kind of known to have some of the best heat distribution in that regard, where the actual cooling of the chip is pretty trash, right? There isn't like a vapor chamber here. Obviously, the MacBook Air doesn't have active heat dissipation, but the chip sits in an intelligent place, you can say, inside the chassis, and the aluminum, the way it's all built, your device will just not get too hot if it has Apple silicon inside. Apple has like temperature sensors even for like where your palm rests are, so it knows that if it gets too hot there, then on the MacBook Air it would need to throttle down the chip even more. On the MacBook Pro it would need to increase fan speeds. So this is where the integration of hardware and software, firmware, everything else like that from Apple comes into play. This is where we also see like the X Elite performing a little better than x86 in general. But yeah, this new generation definitely seems to be doing better than the 8840 HS and than Intel's chips.
Two of the coolest running laptops in this category. And more importantly, their peak temperatures are significantly lower than anything we've tested before. These are also some of the quieter laptops here as well, at least in their highest performance mode. But every laptop here sounds like a jet engine compared to the passively cooled MacBook Air. Now, I think you all have one thing. Laptop here sounds like a jet engine.
Okay, they're all like around 45 decibels. Is that highest? Yeah, it's decibels. That isn't too loud. Like it's not like 60, 70 decibels. It's not like a gaming laptop in that regard. But once it gets close to 50, you can definitely expect it to be loud for like your experience, unless you're in an already loud environment, then it won't stick out against it. And yeah, of course, versus the MacBook Air, it's no comparison. And the question is like, I don't even know if the MacBook Pro would necessarily spin up its chip for some of this, right? Or it could do something crazy like running them at like 25 decibels or something like that, basically like at ambient levels, at which point it's not just quieter, but it becomes imperceptible because your like ambient noise level is as high or even higher than that. The wind hitting your window, your own breath, stuff like that. Yeah, and the natural frequency of the universe, of course. The MacBook Air is quieter than the universe
compared to the passively cooled MacBook Air. Now, I think you all have one thing in your heads that's also been bothering my mind as well, and that's efficiency isn't everything.
Yep,
Apple's M series major strength is their ability to deliver extremely good performance despite sipping back a lot less power than CPUs from Intel and AMD. I mean, Asus can run these Ryzen AI chips at just 33 watts, but does that completely kneecap their performance? Well, we'll have to remember, when compared to the ZenBook 14 with its 8840HS, Asus is using about 15% less power for their HX 370 and 365 based laptops.
Yeah, I mean 33 versus 28 watt TDPs. It's not exact science, as I said before, but yeah, it does sort of line up with the exact power metrics that we've seen from AnandTech. As I say time and time again, it does suck that we don't have like benchmark to benchmark power consumption comparisons, because that's what would interest me the most. But it is what it is.
And a whole lot less than similar laptops.
I would love to see the difference between like Blender and Cinebench power consumption levels, and then like having like an efficiency chart where like the wattage divided by the performance is like compared. That would be cool.
On the Ultra 7.
And yeah, by the way, we are looking at the design again. It does look really a little bit unfinished. Like the edges look like a little harsh to me. And because also you have like these lines, those are almost like invisible, but you can still see them. The same goes for the trackpad. There's like no empty space, which sounds good for like usability, because you get like a really large, nice trackpad. But the question also arises, like, artistically, you would just want like a millimeter here, a millimeter there, just a little bit little bit of space, because you can also see like you have here no gap, but you have a little bit of a gap here before this harsh line, and then basically a symmetrical gap to like the fan, not fan, like speaker perforations. That actually looks quite good, but then it doesn't have symmetry to how it looks below. Again, it's nitpicking, but I do notice stuff like that.
5H. Meanwhile, these chips have more cores and threads than Zen 4 series chips. But those extra cores do count for something though.
Okay, Cinebench R23, completely meaningless already for the M3 chip. We've already said R23 was garbage for x80 for ARM. Also completely meaningless already for the X Elite, so you can fully ignore these already, which is unfortunate because it's not like it costs you money to install Cinebench 2024. And also, by the way, some people will say, well, what if they test both? No. If a test gets improved and it's based on a newer version of the actual software, then that's what you have to use. When it comes to completely artificial benchmarks, supposedly like Geekbench, then maybe there is some value between testing. Oh, it's like pre-AVX 512 optimization. Oh, it's pre-scalable matrix extensions, stuff like that, or scalable vector extensions. I always forget which ones. No, SME, yeah, I think that's what changed with M3 to M4. But that could make some sense, even though I still would always recommend just using the latest version. But yeah, in Cinebench, there's just no reason anymore to test R23. It just has like no scientific value, like in the way that it breaks down individual results, the way we like saw from AnandTech's spec benchmarks. That's just not the case with Cinebench. It just doesn't give you the insight, so you might as well ignore all the results.
And all core tests like Cinebench R20.
But yeah, it wins here. But again, this is a 12-core chip versus an 8-core chip. So you can really feel the difference that a lot of those chips are actually Zen 5C based. Because obviously, if we just had 50% more performance cores, you would expect far, far bigger gains. And yeah, what is like disappointing to me is like the 365, which is like a 10-core chip, right? It's 4 Zen 5 plus 6 Zen 5C cores. That comes in below the 8840HS. But of course, they all beat the Core Ultra 7. And yeah, no ARM comparisons here. Completely worthless to include them in R23.
23, the Ryzen AI 9 365 is able to at least match the 8840HS while consuming less power. The HX370 sprints to a pretty massive lead as well, and compared to the Intel CPUs, well, it isn't even close, even with those being more power hungry. Moving on to something like Cinebench 2024.
Thank you. You can see that Qualcomm noticeably improved here. This is a multi-core test, so you can see that M3 doesn't benefit too much, but it's not as far behind against Intel or something like that. But yeah, obviously, in terms of power consumption, though, the M3 just doesn't exist in the same world as these other chips. We've had like this graph, right? Like this chip has like nothing to do in a discussion that includes something like the Core Ultra 7 155H. Like at that point, you should probably more likely include the M2 Pro. If you're really, really like interested in like matching pricing, maybe not use the M3 Pro or whatever, but like the M3 Pro is the actual chip to compete here. That was before we had single core results.
Way out in front. The only thing that beats them is the X1E 78100. Now, when we switch to single-threaded results, the two Zen 5 chips pretty much dominate.
Okay, so you can, by the way, see again that even though M3 does come close to winning in Cinebench R23 single core, it still doesn't win. But yeah, compliment again to the actual chips we're discussing here, which is Ryzen 300, Ryzen AI 9, which do pull ahead of Intel and the last generation AMD chips.
dominate everything else out there except the 8-core M3 processor in the MacBook Air. Apple has just highly tuned that for lightly threaded workloads, and because of that, it'll walk all over most x86 CPUs.
Yep.
Now, one interesting thing to note is that with our two systems at least, the Ryzen 9 365 was consistently ahead of the 370, but still, what
Yeah,
AMD
again,
has done
silicon lottery, specific implementations, even like desktop to desktop build variants. Maybe one has a like sometimes manufacturers source different fans for their designs, and maybe in some way they like screwed up and gave like the 365 a better fan than on the 370, something like that.
done here is really, really impressive. And the lightly threaded performance uplift, along with some internal
Yeah, this is why, by the way, I'm saying you could put in DM2 here and it still would win versus everything here. This is why I'm trying to say to people, whenever there's a discussion of just how highly Apple's laptops are priced, and I, for example, do agree on the overpriced discussion when we're talking about stuff like memory, I do believe that Apple needs to upgrade us to at least 12 gigabytes of base memory. 16 gigabytes would be very welcome. On storage, of course, 512, I believe, should be standard on anything that is over $1,200. So yeah, just but whenever we are talking about like raw pricing, people just ignore how much efficiency you get here with long battery life. You get like this completely silent operations. If you go for the MacBook Air with 15 inches, that means you actually get even slightly better sustained performance. You get a 6-speaker system that in terms of audio just decimates almost anything on the Windows laptop side already. That's before we even talk about like the 14 and 16-inch MacBook Pros. So yeah, again, good results here from the Ryzen 9 HX 370. You can see that obviously there is an IPC improvement at play here, because obviously though like we were kind of like, granted that's not the 70. Let's actually look at that again. What's the maximum? Like that's the 7940HS general specifications. That goes up to 5.2 gigahertz. This one, the 375, the 370 go up to 5.1 gigahertz. So that leaves us with the 8840 HS. My God, the branding is so confusing. 8840 HS. And that was even like labeled as Ryzen 7, but now somehow the 365 is Ryzen 9. The 8840 HS reached up to 5.1 gigahertz. So there was no 79. I can actually look it up. 89, 40. There's an 8945 HS? No, there isn't. Oh, there is. What does this do? That one goes up to 5.2 gigahertz. Yeah, okay. And what does this do in terms of graphics? Does that clock higher? 2800, which I believe should be about what we had here as well. Or was this 2.7 gigahertz? Yeah, this was 2. Okay, so this is where you get 100 megahertz, because somehow they couldn't match the branding between the 7000 and the 8000 series. The 8000 series goes to the 8945 HS versus the 7940 HS, and somehow the main chip we get from AMD's Ryzen 8000 series is like the 8840 HS, and that one is part of the Ryzen 7 family rather than Ryzen 9, even though it's less differentiated from its Ryzen 9 variant than the Ryzen HX 365 is from the Ryzen A9, then the 365 is from the A9 HX 370. My God, what a branding exercise. Kudos to AMD for, I believe right now, the most confusing thing, especially when it comes gen to gen.
changes have some huge benefits in applications like Photoshop, where the new ZenBooks just demolished every other thin and light Windows laptop we've tested. The same thing goes for Lightroom, where the HX 370 and 365 give you almost unbelievable numbers that come close to the MacBook Air M3. They look like they're from a completely different era, as the media
I mean, not really. Like 1 minute 37 down, and this isn't, again, now granted, this isn't even the highest end version either, but it has pretty much the same GPU and the same CPU as the 375. So this kind of jump, in my opinion, is not too crazy.
Lake CPUs, but those were launched about 8 months ago. In typical Office apps, they perform pretty well, but the spread between all these processors is like splitting hairs. A few seconds here and there, but nothing really extreme, guys.
Yeah,
there is one consistent winner, though, and that's the Ryzen 9 365's dominance over the
Really? I see one clear winner here.
technically faster HX 370. Now, this shouldn't come as a surprise, though, since the Cinebench results showed our 365 system is a little bit faster in single-thread performance, and Office apps certainly aren't multi-core focused. When you get into heavy multi-core focused outputs, those extra threads really do come in handy. But I also want to focus on something else here. Both Ryzen processors are able to get these kinds of results while needing significantly less power than the competition. Their raw performance per watt isn't anything near what Apple can deliver with their silicon.
Wait. Did you give us?
But it is a new high bench performance per watt.
Numbers for that?
While
Why not? This is exactly the kind of benchmark that I want to see. Like comparing performance per watt.
Significantly less power than
like you see, you have like good results here. Like, oh, and by the way, like there's a difference here. Like I believe AnandTech was like testing with Blender 365, Blender 3.6, rendering and simulation performance. Here we have CPU only. Do we have GPU here, or is that only like in graphics performance? Graphics performance, Cyberpunk, Returnal. But we can actually look here at rendering. We can just see the version of Blender. Yeah, it's Blender 3.6. What is up with these websites and using ancient versions of benchmarks? Jesus Christ. Like Blender 4.11, right? There is like, I believe, like a 4.2 preview release. Yeah, exactly. Thank you, by the way, Google. That's pretty helpful result presentation. Good job, Google. But even that is like 5 months old at this point. It's like, why would you not use at least 4.1? This is like a criticism here for AnandTech. And even, by the way, like AnandTech showed like so many like spec results. Like, guys, Geekbench, I know it's like called Meme Bench or Apple Bench, but it's right there and it actually scales really, really well. So the fact that it's not even included, spec and multi-threaded, yeah, it's so weird. This fetishization of Cinebench, which for years didn't even bother to optimize like for any kind of ARM devices, is just so bad to me.
The competition. Their raw performance per watt isn't anything near what Apple can deliver with
time to complete in minutes. Again, M3 is slow here, but again, this is the chip that has they say 8C. I assume that just means 4 performance, 4 efficiency cores, or is that the wait, why do they not say that? Because 8C could apply to the GPU. It could be the what a weird Jesus Christ, why not explain yourself?
With their silicon. But it is a new high benchmark for Windows-based laptops, and that's saying a lot. AMD's integrated video coding engine, or VCE, also got a shot of adrenaline, which is mostly a factor of both chips using the revised RDNA 3.5 GPU architecture. So we're finally...
Well, I think it... Yeah, I don't know. Is that... My question is, whenever we have like weird sub-brandings like RDNA and XDNA, right? I understand that, but like, do we call the actual video acceleration as part of the GPU architecture or something like that? Technically, it's like its own thing.
And I mean, finally seeing Ryzen processors that can beat Intel's QuickSync. It's pretty amazing. And those
Yeah, by the way, this is the result where I was like surprised to see the juxtaposition to what AnandTech showed.
upgrades to encoding and decoding also.
This is where the M3 just kicks butt. This is an SF4K 30 to 4K. This is an H.264 test of a 16-minute video. Apple Silicon comes close to encoding it in real time, 1/3 slower than real time. And yeah, Adobe Premiere Pro failing on the X Elite, not too surprising.
To performance in Premiere outputs that drastically improve on what the 8840HS offers, and it can either match or beat the Ultra 7 155H while running at lower power levels. The other area where there's still room for improvement.
By the way, guys, we're getting close to 2 hours of streaming. I do want to remind you again to please consider subscribing, liking the video, sharing it out to anybody who you think might enjoy it. Of course, comment both while I'm live, but also when the video's already been uploaded. And beyond that, please consider leaving a super chat or a super sticker as a small donation. Or if you want to support this channel directly in a long-term way, please consider becoming a channel member or a Patreon supporter.
Is in result.
Okay, like I try to not focus too much on when people talk about the value proposition of Apple Silicon and completely ignore results like this sometimes, especially when you consider the power draw difference most likely. And when you actually look at this is the M3 MacBook Air, even if you look at the M3 MacBook Pro, which now of course gives you like a 120 hertz like ProMotion mini LED display and way nicer speakers, it gives you a large 72 watt hour battery, so that actually compares nicely, or 70 watt hours versus what is it, 50 something watts on the 13-inch and around 60 watts on the 15-inch MacBook Air. So yeah, you can imagine if it's actually working so much faster through certain workloads while doing so more efficiently, the real world battery life difference is just insane.
Where yes, the Ryzen AI processors are on another level versus Zen 4,
which
but Intel
wasn't DaVinci Resolve optimized for the X Elite? What happened here?
Still delivers better overall performance, though not by much, since AMD has pretty much closed the gap here. Now, those numbers, as you saw, were
by the way, guys, I
these
apologize for my Mac certainly like constantly like connecting and reconnecting to power supply. No idea what's up with that. Maybe my MagSafe cable has been hurting or something.
Tops plugged in, but that's the easy part. The reality for most people
it could
is
be Mac
really
OS
different, because
Sequoia
these are
issue.
mobile devices after all, and they'd be staying away from a plug for most of their life.
Oh,
So did
the
AMD
reverse
make enough
notch.
changes to
That
create
was so
a
ugly.
battery life champ? Now, while these are good numbers, they only tell half the story. We tried our best to match each processor's power range, but one of the challenges when comparing battery life is
50
these new Ryzen AI processors are tied to a 16-inch 120Hz screen. While we tried to level the playing field as much as possible by setting all the laptops to 60 Hz, the S16 size just could account for some of the differences you're seeing here. I can't wait to try one of these Ryzen AI CPUs.
I mean,
more
yeah,
compact.
but this is 78 watt hours, so even the larger screen by itself wouldn't change that much in comparison to the chip power consumption, especially if you set the screens to 150 nits.
14-inch laptop. But even then, with a slight handicap, depending on the scenario, they can match the 8840HS. Though in some cases, the system with the older Zen 4 processor pulls ahead. The same thing goes for the Core Ultra 7 155H and ZenBook 14 OLED. The standings flip-flop depending on the situation. Also, you should completely remove the XPS 13 from the equation here, since the battery life capacity on that thing is just absolutely pathetic. The heavy load numbers surprise me though. I mean, they draw some of the lowest amount of power on average, so shouldn't they get pushed to the top in this test? Well, no. Basically, due to their overall efficiency, ASUS is able to run them at higher continual wattage on battery, and that has a net positive effect on their performance, especially when compared to the Ryzen 7 8840HS. Ironically, the ZenBook 14 OLED does a pretty good job here as well, which is probably why its heavy load times was so bad. Now, it really does feel like AMD
Handbrake video conversion on battery, 75% battery capacity, time to completion in minutes. What? Oh, that's different in terms of like modes, which of course the MacBook Air was just standard.
has finally found the small piece of the puzzle when it
I
comes
mean, you could technically go ultra crazy and put this in low power mode for something especially like video playback if you don't expect to do anything else, and just see how it destroys everything in its path.
to maintaining good overall performance on battery. But there is a small hiccup. While AMD was pretty far ahead in lightly threaded apps like Photoshop when they're plugged in,
This is where we see that this is a result that it can give you both like in regular performance and of course on battery performance, both plugged in and on battery, while the rest has noticeably worse results because some of them not too much worse, but others, like Intel for example, suffers a lot from not being from being on battery rather than plugged in. So you do have to consider that with Windows again. So when people say like how overpriced Apple's MacBooks are and completely ignore that kind of difference in experience, just saying.
their performance relative to Intel, Apple, and Qualcomm takes a dive on battery, guys. Now, while gaming is never ever going to be a primary use for these thin and light laptops, we've got to talk about it since the integrated graphics just keeps getting better and better. And in order to keep their leads against what Intel's bringing a bit later this year, AMD basically decided to give their RDNA architecture a bit of a refresh. And now, it isn't anything major on paper since the 880M gets the same core count as the previous generation 780M, while the 890M gets a pretty big increase to 16 compute units. There's also a pretty big bump in frequencies as well. But did that change make a huge difference?
We've looked at that. It's 1 or 200 megahertz. It's not a big. This is sometimes where I see like this is a natural inclination to like give data, but you haven't done the research because it feels correct, right? Like there is a big clock speed increase, but there isn't.
Difference in the Ryzen AI series ability to actually game? Well, the answer isn't what you might want to hear, at least not in synthetics like.
Okay, so it seems like 8C that they showed before, like either they switched MacBooks in between, or they meant 8-core CPU because those previously were CPU tests. So the fact that the MacBook Air wins here is so freaking hilarious to me. Again, this is a benchmark that should actually be pretty representative of real games. One could argue that the MacBook Air, at worst, maybe will be sometimes held back by its 8 gigabytes of memory. But yeah, and its bandwidth, sometimes maybe it's like 100 gigabyte per second versus a lot of the others being 120 or more. So, but yeah, to me, this is just hilarious to see Apple on top.
Like 3D Mark. In some cases,
But yes, shout out goes to actually them not beating Intel in this specific test, but at least matching it. A very, very small uplift versus the 8840HS, but we see like this difference in power usage, which again, because there is no big node advantage, you cannot make the new architecture that much more efficient, especially not without making a major architectural jump, right? Like the like RDNA 4 will likely be a lot more efficient even on the same node, but not RDNA 3.5 versus previous generation.
the new processors are better than the last gen ones, but they still lose to Intel. And in other tests, they actually struggle against the 8040HS, which is a bit of a weird situation since on paper, they have higher core counts and increased frequencies, at least in the case of the HX370. So what's really going on here? Well, that's where we were wondering, and I think this comes down again to power.
Wait,
because
how
every one of
how
these
big was
laptops
the difference to the
at least-
365, which has like yeah, that just doesn't make sense. That has like 1/4 fewer compute units. That difference should be a lot larger.
in the case of the HX370. So what's really going on here? Well, that's where we were wondering, and I think this comes down again to power, because every one of these laptops treats their CPUs and integrated graphics very differently. The ZenBook S16 might not just be feeding the 880M and 890M GPUs with as much power as the other laptops feed their GPUs, or they're just prioritizing CPU performance and funneling as much as juice as possible to the processor cores rather than the graphics subsystem.
But you could also ask, like, if you have like previous generation APUs that come in about the same amount of bandwidth, you could argue that especially on an APU, a system on a chip, and something like that, not getting a major memory bandwidth boost because you don't support that much faster memory is actually going to be a big limiting factor. Whether or not it's enough to prevent any uplift, that's very unlikely, but it could sometimes have or even like reduce it to like 1/3 or of the potential benefits. We saw that sometimes with like M3 versus M2, which had undeniably a faster GPU when it comes to raw performance, but in memory bandwidth limited benchmarks, it showed, guess what, very little improvement because it didn't have either that much more cache to increase effective bandwidth, or it didn't, and it simply didn't have faster bandwidth or larger memory bus.
Game testing does go a long way towards proving this point, since games that are really CPU focused seem to see the biggest wins for these new Ryzen AI processors. In some cases, the HX 370 and 365 are way ahead of the previous generation.
Yeah, this is scaling that I think could make sense even with like the difference of compute units. If you are pretty close in power consumption, those differences are actually pretty positive for the 370. Of course, as I said, there's memory bandwidth to consider, which shouldn't be different between those chips. The 365 matching the 8840HS performance at likely much lower power consumption is probably a very good sign of what this chip could mean for like the gaming handheld space for Windows devices. So yeah, in my opinion, definitely better than nothing. Of course, it is now like by most accounts the fastest integrated GPU on a Windows device. Yep. I don't think I need to take that comment back. At least I don't think so. Obviously, versus Apple Silicon, it's incomparable because technically even the M3 Max has an integrated GPU, and that obviously is a chip in a completely different class in both of power consumption, heat generation, things like that.
And simply
and of course,
steamroll everything that Intel has to offer. And if you look at Snapdragon, well, they're just on a completely different planet. Now, when you shift gears to games that are a bit more GPU limited, things get a little different.
By the way,
Actually,
like just small.
Now, when you shift gears to
criticism
games that are a bit more GPU limited, things get a little different. Actually, this looks pretty bad for Ryzen AI processors and RDNA 3.5. Get a little different. They're just on a completely different planet.
Small like criticism here. Baldur's Gate 3 has a native ARM version that I believe is even like fully metal optimized and everything for Apple Silicon. Not including it is actually kind of insulting in my opinion, because it would be such an interesting test, and you do want those tests to be running at the same settings, and sometimes you just cannot find results on the web that have the same settings. So if they could like establish at least a few more results for Apple Silicon, because it sucks that we now have more games but they just don't get tested properly.
Now, when you shift gears to games that are a bit more GNA 3.0 and other games, the Ryzen
so Cyberpunk, this is with FSR in order to reach anything close to 60 FPS. Still don't know why they test 1200p. I assume that's 1200p in like a 16:10 aspect ratio of like 1900 by 1980 by 1200. Yeah, but it is faster here than everything else. Slightly disappointing to see the 365 underperform the 8840HS. Maybe this is where like the more simple CPU design with like 8 performance cores comes into play here. But again, it could be like so many different variables here.
Consistently beaten even with its new architecture. So basically all of this points towards the possibility that ASUS might need to look a bit closer at how they allocate power on these new laptops. When their algorithm detects a 3D workload, more juice should be shifted to the integrated graphics, just like they did with the 8840HS in the ZenBook 14 OLED. Because right now, the S16 is at a huge disadvantage in gaming, even though on paper, 2 Zen 5 processors that we have.
Spider-Man Miles Morales, yeah, 1% lows, definitely the best actually here. Well, you can see that's again, the scaling here is really weird to me. So it might be, of course, that the Ryzen 300 chips are still gonna get improved simply with like software updates, even not like special updates for the individual games, but just like updates by the manufacturer, just from AMD in general when it comes to drivers, things like that.
Over here should have a clear advantage in every situation. So at the end of the day, did AMD accomplish what they set out to do? To be honest, I don't think I've ever been excited about these new laptop CPUs for years, minus the ridiculous naming scheme. It's not about what the ZenBook S16 did here.
But by
It's
the way,
more
there's like AMD's MacBook moment. There should be like a question mark here. No dot.
What it could be doing in the future. Because we haven't seen these Ryzen AI processors in their fastest form yet. These things over here are just running at 33 watts, while their higher-end SKUs is just much higher. And you might be wondering why Asus chose a relatively low-wattage CPU for these ZenBook laptops. And that's pretty simple. These chips just don't need more. They cleanly beat the Ultra 7 155H in almost every test while consuming less power and it also producing less heat. And that's a major win for AMD and laptop manufacturers as a whole. But that being said, there obviously needs to be work done with their partners to properly direct power towards the integrated graphics engine when a gaming situation pops up. If not, we get what we saw with the S16, basically an underlying RDNA 3.5 graphics core that gets beaten in areas where it should be dominating. There's also some serious irony here as well, and I think this can be a separate video, but the biggest part of AMD's name change is the AI tacked into the Ryzen name, and it has little to no real-world use for most buyers. I mean, sure, the new NPU is a beast on paper, but for now, it is just marketing fluff, so don't fall for that
it's
BS.
Just
Another issue will be availability, because there's only going to be a handful of laptops with the Zen 5 around until at least October. Even the 365H equipped ZenBook S16, I believe, is a Best Buy exclusive. I'll leave links down in the description if you're interested in checking them out, but I should also mention that the HX370 version will be on the Asus store at first. In the end, I think AMD did something that Qualcomm and Microsoft's ridiculous Copilot plus PC marketing didn't. They delivered a platform that might have AI chops for the future, but it also features top-shelf performance for apps.
I think that's a relatively fair conclusion. I still think I would have liked for this not to be a sponsored video in any way, but like, well, I don't want to say anything wrong. It is sponsored, right, by this by Asus, right? They usually like say that only like minutes later, or no? Is it? Well, that's an ad. That doesn't mean that the video itself cannot be sponsored by somebody else. It would be cool if it weren't sponsored.
Instead of yet another
Thermaltake, check out the ZenBook S16 Best Buy. What are people saying? Large tech companies try not shove this letters AI literally everywhere. Challenge impossible. Has some HDMI sticker on it. Yeah. Do the letters A and I come with a price increase? So maybe it wasn't sponsored by Asus. Again, I don't want to insult them in any way. I know they've done a lot of recently like somewhat questionably sponsored content. But yeah, if I am wrong here, please let me know. Because they do obviously have like the Thermaltake here tower for the sponsor. This video is sponsored by Thermaltake. Okay. Review unit provided free of charge by Asus as per Hardware Canucks guidelines. No review direction was received from manufacturer. Okay. So that's definitely good. Yeah, but not a giant uplift here. So I think that's about enough info for today. I do want to, at the end, briefly say some news that I just read, which is that Apple Silicon by Apple is getting delayed to Apple AI to October, but we will be getting an Apple Intelligence beta soon, basically, with the iOS 18 betas, like next week or something like that, I just read. Let me know. I'll just briefly check on my iPad. So it's according to Mark Gurman, iOS 18.1 Beta 1 launching as soon as this week. Wow, that's interesting, which I assume means like if the week starts with a Sunday, right? So, but that's interesting. So that's, but for everyone else, it will be coming with iOS 18.1 in October. So that's the big news we got while streaming today. So I hope you guys enjoyed those last minute leaks. Maybe we'll talk about it with some other Apple news sprinkled in future videos. Maybe there will be one tomorrow, most likely on Tuesday though. Let's see also how these Ryzen 300 reviews keep building and but yeah, we've seen some good numbers, definitely nothing game changing, very much what you would expect from a processor that is still basically on the same node. Like, it's not even as much of a jump in terms of nodes as M3 to M4 coming from N3B to N3E. So I cannot hold it too much against AMD, but it's definitely not going to get me out to buy a Windows laptop anytime soon. That being said, I'm about ready for today. I want to give a last reminder for you, if you're watching this live or non-live, to please consider subscribing to the channel, liking the videos, sharing them out, commenting on the channel. And of course, as always, if you want to support this channel directly, please leave a small donation in the form of a super chat or a super sticker, or you can become a channel member here or a supporter on Patreon. So just briefly check if everything's working all right. No more questions. Thank you guys so much for tuning in. As always, let me know what you would like to see me cover next. I'll see you guys soon again. This is AnandTech tuning out.